Hello and welcome. In this short and quick video, I'll be talking about bubble sort, which is one of the simplest sorting algorithm. First, I will show you how bubble sort works, and then let's quickly do a implementation of the bubble sort. In bubble sort, what are the key things to remember? Let's first check that. 1. What happens in each iteration or say loop. 2. For how long do we need to run these loops? Okay, so answer to the first one is, what you do is you compare adjacent numbers. Then if not in order, then swap. Not in order means if the first number is larger than the second number, then you just swap them. So your objective is that you are fixing the order of two numbers, and in doing this, the end result or what you would achieve in each iteration is that the largest number from the unsorted part of array moves to the end of array. Okay, for how long do we need to run these loops? Since you are comparing adjacent numbers, and every time one number is moved towards its right position, then what you have to do is you have to reduce the loop by 1 each time. So we will see this in the implementation also. Okay, let me do a dry run of one example. We'll take one example and we'll see how the binary sort works. So let me take an example like 9, 5, 3, 1. Okay, now what I'm going to do is I'm going to take these two numbers and I'm going to verify whether they are in the order or not. Okay, they are not in the order, so what I do is I swap them. Now my array looks like 5, 9, 3, 1. I started from here and I compared, let's say this is the position where I equals to 0. Okay, so I compared I and I plus 1. Okay, so I compared these two numbers and I found that they are not in the order, and then I swapped them. Now I move to I equals to 1, and now what I have to do is I have to again compare the next number with it. As I see, 9 and 3 both are not in the order, so I just swap them. Now the array is looking like 5, 3, 9 and 1. I repeat the same thing, I equals to 2, and I compare with the next number, and we just swap them because they are also not in the order. 5, 3, 1 and 9. So you see, this was the largest number and it is now in its right position. First point to remember, since we are comparing two adjacent numbers, like every time I am performing this operation, compare I with I plus 1. Okay, so you have to run the loop in such a way that this index is within the bounds of array, which means if my indexes are 0, 1, 2, 3, I is I plus 1 is not greater than 3 anytime. This is this is a general mistake that happens while implementing for the first few times. So your loop should be running till I equals to 2 only. And now another thing, this is not sorted, like this is only the first iteration, one run, one pass of this array. You still have 3 elements which are not in their right position. So now it looks natural, right? Like I don't want to go again and compare the last 2 elements because they are already in the order. Because if one element out of 2 is in the order, then definitely the second one is also in the order when compared contextually within the local bounds. Like if I have to just compare 1 and 9, they are in the order. Like 1 might not still be in its final position, but when compared with 9, it is in the final position. So there's no need of me doing this comparison. Even if I do, it is going to not swap the numbers and will not have any effect. So it's an extra work that I will be doing. Now 5, 3, 1, 9. Let's do the same thing again. 0, 1, 2, 3. And now I will be comparing 5 with 3. I see that they are also not in the order. So 3 comes here, 5 goes here, and 1 is here. Now I compare 5 and 1. I'll see that okay, 5 is bigger than 1. Let's swap these. So now my array is looking like 3, 1, 5. You see, in the second pass also, what happened is 5 came to the end of this array. 9 was already here. We'll keep 9 as it is. So again the maximum element is reached to the end of this array, and second time I will be just comparing these two numbers in the next pass. Now my array starting is 3, 1, 5, 9, and now I have to just compare these two elements, and 1, 3, 5, 9. Now my array is in the sorted order. This is how bubble sort works. Let's do a quick implementation also in the code and see how bubble sort works. I'm going to write a function and name it bubble sort. Let's say it just accepts one array, and as I said that we would require two loops here. One is inner loop and one is outer loop. Okay, and one more important thing, as I told that we will be doing two adjacent elements comparison, and I never want to cross the bounds of array. That's why I am running my loop till one less element, like one less than the length of array, because we are already doing plus 1 for in the indexes while doing the comparisons. What I also want to do is I also want to reduce it by 1 every time. That's what we spoke about. Okay, so this is quite simple program, and I'm just returning array from here. Also let's call it with some sample data. me take the similar example, 8 8 7 1. Okay, 1 7 8 9, this is the right order and the numbers are in sorted format. This is how bubble sort works. That's all for this video. Thank you.